All right, PIBA students, it's time for another activity from topic 9. In this activity, we're going to be putting the standard deviation together with the normal distribution, the symmetric mound-shaped distribution, to see an amazing property that the normal distributions have. And it's a great property that allows us to compare different normal distributions and to say some very specific things about them. So we're working on this thing called the empirical rule. That's the goal of the activity. Okay, so the specifics of this activity, we've got a whole bunch of placement exam scores. There's 213 observations altogether. Okay, and some work has been done for us, thankfully. We don't have to figure out the mean. We know that that the mean is 10.221 points. And the standard deviation is 3.859 points. Okay, so those have been worked out for us. And there's a picture here of the distribution, right? And then here's a table. Okay, so there's enough information in the distribution to reproduce the table in this case, and vice versa. Okay, so they contain the same information. All right. So first question, almost rhetorical. All right. Does the distribution look like it's roughly symmetric and mound-shaped? Okay, it's not perfect. Okay, but you know, if we look at it, right, you can kind of put a normal curve on that, right? It's not perfect. It's got some bumps on it, but roughly it's got that symmetric and mound shape to it. Okay, we never get the perfectly smooth distribution, right? This one's not bad. Okay, all right. So now we want to answer a bunch of questions, and they don't seem like they're taking us anywhere, but they really are. Okay, so let me go through the questions first, and then we'll switch over and start to answer them. Okay, so the first thing we're asked to do is we're supposed to subtract the standard deviation from the mean, and then add the standard deviation from the mean. And that will give us two bounds, a lower bound and an upper bound, that measures what's within one standard deviation of the mean. Okay, and so our job will be to figure out how many and what proportion of our scores fall within one standard deviation of the mean. Okay, and then we're going to go out another standard deviation in each direction, and we're going to figure out how many and what proportion of the scores fall within two standard deviations of the mean. Okay, and then we'll figure out how many and what proportion of the 213 scores fall within three standard deviations of the mean. All right. Okay, so I wanted to do that all on the slide, which is really clear, and now we'll kick it over to my paper, which is a little blurrier, but where we'll do our work. Okay, so we've got our standard deviation here and our mean here. Okay, so our mean is 10.221. So our mean's right about here in our distribution. And what we're going to do is we're going to move one standard deviation to the left and the right. Okay, so when we subtract one standard deviation, okay, our standard deviation is S, our mean is X bar. When I subtract one standard deviation, I get 10.221 minus 3.859, and that is 6.362. Okay, when I add a standard deviation, I get 10.221 plus 3.859, and that gives me 14.08. All right. So what I'm doing is I'm going down a standard deviation to 6.362, and I'm going up a standard deviation to 14.080. Okay? So this I could call X bar minus a standard deviation, and there's X bar plus a standard deviation. And here, look at. These are all the observations that are within one standard deviation of the mean. Those are the students who scored reasonably close, right, to the mean on their placement exam. Right? And our job is to figure out how many, right? So that's part C. Okay, Now, one thing to be a little careful of, right? If you scored a 7 on the placement score, you are within standard deviation. You're within one standard deviation because the standard deviation, going down one standard deviation from the mean, takes us to 6.362. So 7 is a score that's within one standard deviation, but 6 is not, right? Because if I subtract one standard deviation, I have to go farther to get down to 6, all right? So, and on the other side, right, if you score a 14 on the placement exam, then you are within one standard deviation. But if you scored a 15, you're beyond, right? Okay, so what we need to do is we need to count how many scores fall between 7 and 14 inclusive. Right? So including the 7 and the 14. Okay, so let me go up to the table. And so we're taking 16 plus 15 plus 17 plus 32 plus 17 plus 21 plus 12 plus 16. Right? So I add those up and I get 146. So 146 out of 213, or approximately 0.685 if you work it out, of our observations are within one standard deviation of the mean. Okay, that makes sense? So about 68% of our observations are within one standard deviation of the mean, right? And that makes sense, right? If you're looking at the bars, right, most of our bar area is in that one standard deviation, okay? All right, so that's C. Now, let's go on to D. And we're going to stretch it out another standard deviation. So we're going to go down 1, and up 1. Okay, so if I do x bar, the mean, minus 2 standard deviations, right, I'm subtracting another standard deviation from that, from the 6.362, right? So that's going to give me 2.503. And if I go up another standard deviation from 14.080, so going up, right, that's going to take me to, 17.939. Okay? So those are our limits. X bar minus 2 standard deviations and X bar plus 2 standard deviations. Right? And now you can see that most of our observations, almost all of our observations, are between those bounds, right? So, this time now we're going to count the number of observations between 3 and 17, right? Because 2 is too low and 18 is too high. Even though 17.939 would love to round to 18, if you scored an 18, you are beyond 2 standard deviations, so we're not going to count you. Got it? Okay, so then to our 146, we're going to add 5 and 7 and 12 and 13. And we're going to add 8 and 4 and 7. Right? To our 146. And so when I add those in, I get 202 scores. And so 202 over 213, or about 0.948 of observations are within 2 standard deviations of the mean. Okay? That makes sense? All right. One more time. We're going to go another standard deviation out in each direction, and maybe you can see what's going to happen, right? If I go x bar minus 3 standard deviations, so I subtract another standard deviation from 2.503. If I subtract 3.859 from 2.503, I get a negative number. Yikes. Negative 1.356. Okay? And if I add another standard deviation on to 17.939, I get 21.798. And look at, oh, this is F, I guess. F. No, that's E. Sorry, that's E. This is D continued. All right. And now look, all of our observations are within 3 standard deviations, oh my, of the mean. Do you see? Okay. All right. So we've answered all the questions from activity 9-4. We've done our job. Now, what's important is that what we have observed here happens in virtually all normal distributions or symmetric mound-shaped distributions in one form or another, at least approximately. Okay? And that's what we call the empirical rule. Okay? So let me switch back to my slides. Okay? So here's what the empirical rule says. It says when you have a mound-shaped symmetric distribution, normal, okay, like we just saw, this is what happens in general. About 68% of the observations fall within 1 standard deviation of the mean. Okay? About 95% fall within 2 standard deviations of the mean. And then virtually all, okay, and to be precise, about 99.7% of all the observations fall within 3 standard deviations of the mean. Okay? That's what we call the empirical rule. Okay, and you can picture that sort of more generally. All right. So there we go. There's our normal distribution. We go down a standard deviation and then up a standard deviation. In that range is 68% of our observations, at least approximately. Okay? And then if we go another standard deviation, then 95% of our observations fall within 2 standard deviations of the mean. And then once you go up and down another standard deviation, you might not get quite everybody, but you get virtually everybody. Okay? And remember that these curves I've drawn here, or the curves we have drawn here on the slide, are idealized, right? So in practice, what we have are these very bumpy things, but these are bumpy things approximate our normal curve. Okay? And that's our empirical rule.